Okay, let's give you guys some more practice. So as usual, I'm heating up some water in this weird looking pot here, and currently the temperature down here is at 100 degrees Celsius, and the temperature here is 30 degrees Celsius. So now I'm going to put out the fire. So currently it is 100 degrees Celsius down here. It is 30 degrees Celsius up here. I'm now going to add boiling water so currently at the moment this level here is at 8. So 5 is here, 8 is here, and 10 is here. Okay, so currently it's at a level of 8. Now I'm gonna top it up to level 10 with boiling water. So this here is boiling water. So here is 100 degrees Celsius. Here is 100 degrees Celsius. Here it's 100 degrees Celsius, and so on. So it's 100 degrees Celsius all around here. Okay, so down here is 100 degrees Celsius, and then there's a smooth gradient all the way to 30 degrees Celsius. And then I'm going to top it up to a number 10 level, and then this is 100 degrees Celsius. Now if I were to stir this up, what temperature will the water settle at? So really, it's me asking you to find the average temperature. Okay, so it's 100 degrees down here, 30 degrees here, and then 100 degrees all around here. And if we were to stir up the water, what temperature will the water settle at? Okay, bear in mind that this level here is 8. Okay, so press pause and have a go. Okay, so to do this here, we need to take this into account. Well, to do this here, the average temperature is given by this. The average temperature is given by this. So hang on. So this bit here is from here to here. Okay, and then from 8 to 10, from 8 to 10, from 8 to 10 is given by this. Okay, and don't forget the temperature is always 100 here, and then we're going to divide it by the whole thing, or the whole volume is given by this. Okay, so hang on. So to set up a model from here to here, we need to sum up all the disks from 0 to 8. So from 0 to 8, and then we've got to take the temperature into account. So taking the temperature into account is really U. Hang on. So remember, we're summing up everything from, hang on, this bit here is really us taking care of the blue section here. Okay. So remember, it's from 0 to 8. So oops. So the blue section is from 0 to 8. Okay, and this bit here is the temperature. So really, for the blue section, we are trying to set up our model in such a way that, well, if you draw a graph of temperature, don't forget our temperature is a smooth gradient from 100 degrees Celsius to 30. So if you plot a graph of temperature and the Y value, because remember we're summing up all the disks, so it's moving in the Y direction. So well, we want to set up our temperature gradient in this way, in such a way that when Y is 0, the temperature should be 100. So when Y is 0, the temperature should be 100. Okay, and then by the time, so we are summing up all the disks, so it's Y that's moving about. By the time Y gets to number 8, our temperature should be at 30. So by the time Y gets to 8, our temperature should be 30. So this here should be 30. So to set up our gradient, our temperature gradient here, we need to come up with an equation for this line. Well, the equation for that line is given by this. Okay, well, the equation for this line here, well, we need to find the gradient. The gradient will be the height, which will be 70. Okay, the gradient will be 70, and the the width here is 8. Okay, and don't forget it's a negative gradient because it's going downhill, so we need to stick a negative in there and the y here. So our temperature is given by this. Okay, our temperature is given by this, and don't forget we're summing up all the disks. We're summing up all the disks. Well, if you look at this one particular disk, the thickness associated with this disk is dy. That's this dy here, and then well, to get the area of the disk, we need to pi r square it. Well, the radius of this thing here, the radius here is given by root y. Square root both sides. Yeah. So the radius is given by root y here, and then when you square it, it becomes pi y. Okay. So well, we've done this many times. So the blue section is given by this. The boiling water part right at the top is given by this. So the red part here is given by this. So it's really us evaluating this. Okay. And then don't forget this is from 0 to 10. Okay. So evaluating this whole thing here. Well, notice that you can factor out the pi. So pi's in common, you can actually factor out the pi. So it becomes this, and then the two pi's will cancel each other out, giving you this, and then it's just a matter of evaluating it, and then it's blah blah blah, and it should give you a temperature of roughly 70 degrees. So hang on. So right from the beginning, this here is 100 degrees Celsius. This is 30. Okay, we put out our fire, and it's currently 130. If you top it up with boiling water and then stir it, so you stir it, if you stir it, it should settle at roughly, I think it was 70 degrees Celsius. Yeah, it should settle at roughly 70 degrees Celsius from 0 to 10. It should be 70 degrees Celsius. All right.